Okay, so we just finished going over the homework, so if you were absent today, you can check the homework. It's online, attached to the notes. Today what we're going to talk about is some application of the permutations, combinations, and counting principle in finding our sample space, and then we're going to use those sample spaces in probability. But before we get started, we have to look at some terminology and some symbolism in mathematics and what it means and what it stands for and how we're going to use it. Okay, so we're starting out in our workbook, and we're on page 421. Okay, so what we're going to look at is set theory, and that is helpful in calculating our probabilities. So a set, what is a set? It's a well-defined collection of distinct objects. And many times for us in mathematics, those distinct objects are numbers. Okay? So each object in the set is called an element of the set. So I'll refer to elements of the set, and those are just things that belong in that set, the numbers that are in that set. A set may be specified by writing its elements in braces. For example, the set S of prime numbers less than 10 could be written like this. The set S contains 3, 2, 5, and 7. And so with a set, we would use the braces at the end to denote a set. So the number of elements in a set, N of S, and we've actually already talked about this, the number of elements in a set, for this set, how many elements were in that set? 4. There were 4 total objects in that set. So with a set with no elements, we call that the empty set, and you guys are already familiar with the circle with a slash through it, or we can have the braces that have nothing in it. Those are the empty set. The set of all elements under consideration is called the universal set, and we denote it with a capital U. Now here we have some more symbolism. All right, set A is a subset of set B if every element of A is also an element of B. Okay, so here it says A is a subset of B. So this kind of C-looking thing, sideways U, you can think about it, that means subset.
Why are they all the same symbol, just turned sideways? Like, do they not want to make a new symbol for each, like intersection and union?
They're lazy people.
Yeah, just the way it is. Okay, intersection. Intersection and union. Have you guys already seen intersection and union before? Anyone? Okay, intersection of sets is the set of all elements that are in both. What do they have in common? And when you do a Venn diagram, that's this part in here, what they have in common. And sometimes with our Venn diagrams, we might have numbers out here. Okay, so set A would contain 1, 2, 3, and 4, and set B would contain 2, 4, 6, and 8. So their intersection, what elements are in both sets, would contain 2 and 4. So we would say the intersection of A and B contains 2 and 4. Does that make sense? Okay, so this upside down U is our intersection. So they must be in both if they're in the intersection. The union is the set of elements that are in A or B. So intersection has to be in one and the other, union one or the other. So if we stuck with my previous example, the union of the sets A and B would contain, that doesn't look like a brace, 1, 2, 3, 4, 6, and 8. set A is the set of all elements in the universal set that are not in A. So the little c up here means complement. Okay, so if the universal set was the numbers less than 10, if I said the universal set let's just say integers less than 10. No, because integers would go on forever. Whole numbers less than 10. What would be if A was 1, 2, 3, and 4? What would be in the complement of A?
5, 6, 7, 8, 9.
5, 6, 7, 8, 9. Is that it?
Yes.
1, 2, 3, 4 are in A, so they're not in its complement. 0.
Would they actually have to write 0, or would it just not be there and not be 0? Like,
If I said whole numbers, you'd have to do 0. If I said natural numbers, you wouldn't list 0. Okay. Any questions about the symbolism? Okay, let's flip over to the next page. It says, recall that a probability experiment is an activity involving chance. Each repetition of an experiment is called a trial. So every time we perform the experiment, we're doing a trial. And each possible result is called an outcome. The sample space of an experiment is the set of all possible outcomes. So, if I am flipping a penny, what are my possible outcomes? Heads or tails. That's my sample space. It includes heads and tails. If I'm rolling a die, 1 through 6, that's my sample space. Okay? An event is a set of outcomes. When all possible outcomes of an experiment are equally likely, the theoretical probability that event A will occur is given by this. N of A over N of S. So it's the probability of event A occurring is the number in A over the number of the sample space. Okay, so here we go. We're going to roll a number cube. And I'll call it a die. That way y'all don't want to gamble. Okay, so we're going to roll a number cube. Event A is rolling an even number. Event B is rolling a prime number. Calculate each of the following probabilities. So, what are the elements in set A? 2, 4, and 6. What are the elements in set B?
2, 3, 5.
1,
2, 3.
1,
1, 3, 5. 1, 2, 3, 5, or 2, 3, 5. 2, 3, 5. Okay. 1 is considered the unit, and it's not considered prime. 2 is our first prime number, and it is our only even prime number. Okay, so the probability of A is the probability of rolling an even number. To calculate the probability of A, first identify the sample space. All right, so what is the sample space here? 1 through 6. So there are 6 possible outcomes. Probability of A, I just wrote right there. The elements in A. So there are 3. So it's favorable, the number of favorable outcomes over the number of total outcomes. So 3 over 6 is 1/2. the probability of A union with B. A union with B. What is contained in the union of A and B? What elements? 2, 3, 4, 5, and 6. So, what are the number of elements in the union of A and B? 5. So what is the probability of A union with B?
5, 6.
5, 6. Okay, you try. C.
The numbers that are in
Okay, so when we look at A and B, the only element that's in both is 2. So there's one element, so it'd be 1 out of 6 or 1/6. Okay? So, the last question says the probability of the complement of A. Well, if A is rolling an even number, the complement of A is rolling an odd number. So wouldn't it also be 3 out of 6 or 1/2?
Yep.
Okay. Any questions? All right. On the next page, it just shows us that the probability of an event occurring, along with the probability of its complement, must equal 1. Because the probability of it occurring plus the probability of it not occurring has to total 1. Okay? So we can find probabilities by subtracting the complement from 1. Or we can find the complement by subtracting the probability of an event occurring from 1. Alright, now the next one. On the next one, we are not rolling one number cube. We are rolling 2. Okay? And so, what are possibilities? There are 2 different colors. We have a blue one and a white one. And even if they were the same color, we would still have all these possibilities. Okay? So, this would be 2, 2. This would be 2, 3. This would be 2, 4. This would be 2, 5. This would be 2, 6. 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So, what is n of s? When I roll 2 dice, how many different possibilities are there? 36.
That's 5.
36. And we see them right there. There are 36 possibilities. Okay. So, if they ask us to find the probability of rolling doubles, how many are doubles? Doubles, 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 doubles. 6 out of 36. So the probability is 1/6. So if the probability that we roll doubles is 1/6, what is the probability that you do not roll doubles? So it's going to be 1 minus that 1/6, which is 5/6. Okay? What is the probability that sum less than 4? How many of these have a sum less than 4? 1, 2, 3 of them. So it'd be 3 out of 36, which is 112. So what would be the complement to that?
33, 36, or
11, 12.
11 twelfths. So it'd be the sum that is greater than or equal to 4 is another way we could state that instead of the complement of this event. Okay, any questions about how to visualize your sample space and use that in probability problems? So sometimes you'll be given all the information you need and sometimes you'll have to visualize it. Okay, is this the one y'all have? Is this in your workbook?
Yes.
14, and that's not the one. Okay, real quick here, let's take a look at a couple of these. Quickly try 1 through 6.
Is it just a fraction?
Mm-hmm. Okay, as soon as you're done, take a look up and see how you did. See if you have any questions for me. Okay. Any questions on 1 through 6?
How'd you do number 3?
Number 3? Okay, see this is A union B, so it's everything in A
Yeah.
and B. So to A, we're going to have to add the 7 and the 9. So that would be 8 elements that are in that union, and so 8 out of 10. Okay, number 7, a bag contains 5 red marbles and 10 blue marbles. You choose a marble without looking. Event A is choosing a red marble. Event B is not choosing a blue marble. Okay, so the event A is red. B is not blue. So we want the intersection of A and B. The intersection of A and B. No, choosing a blue. I'm sorry. Choosing a blue. Okay, so which marbles are red and blue at the same time? None.
Magic ones.
None. So, is there anything in this set? No, that set is empty. If the set is empty, what's the probability of that occurring?
None.
0. There were no elements in the set of the intersection of A and B. Therefore, the probability is 0. Does that make sense?
Is it the 0 with the dash through it?
This could be here. The set looks like this. It is
but
the
the
empty
probability.
set. But the probability is 0.
Okay, thank you.
Okay, number 8. A standard deck of cards has 13 cards. Standard, just telling you about that. You choose a card from the deck at random. What is the probability that you do not choose an ace? Well, you may know exactly how many cards are in there, but how many aces are in there? 4. So the probability that we choose an ace is 4. So 4 out of 52. So the probability that we do not choose an ace is just the complement of that, isn't it? Not an ace is 1 minus that. So it would be 48 over 52, which reduces to 12 13ths, right? This was 1 13th. Okay.
So for compliments, can you just opt out?
Yep. 1 minus. All right. The other thing we're going to talk about real quickly, we talked about that already, so I'm going to skip that. We know how to use this chart to find a sum. Which ones have a sum that is 8? Well, we can look at our chart and go, that's 8. What else is 8?
4 and 4.
4 and 4. What else is 8? What else is 8? What else is 8? So how many elements are there? 5 out of 36. We know how to read that chart. With experimental probability, sometimes we're given information and we just do favorable over total. So what would be, if we actually did an experiment, that's where you count. Okay, I spun the spinner. It landed on red 30 times, yellow 25 times, green 12 times, blue 33 times. So if they asked me for the experimental probability of spinning red, it would be 30 out of the total number of trials. So how many total trials were there? So it would be 310. Good, good. Okay? So experimental is where they'll give you data from an experiment. Theoretical is where you think about what could happen. What are all my possibilities of dice and looking at those. Experimental means an experiment has been performed, you have data, and you look at the data and do the favorable over the total. Okay, you may grab your phones. Ladies first, gentlemen second.
Claudia, what number is yours?
It's 6.